Hey hackers, welcome. I've been one of the co-founders of the AEC Hackathon, so I really love these events, but my big focus, my profession, I would say, is mass timber and digital fabrication, and I work with Stefan Schneider, who will introduce himself after this, and I look forward to sharing our slides and decks and just talk about what we're doing in mass timber. Stefan, of course, can give you a very European perspective since he is Swiss. And then we'll talk about some upcoming events we're also organizing for mass timber, including an online hackathon. And Stefan?
Hey, thanks, Greg. Hi, everybody, and welcome. Happy to be here with you all, although if we're just here virtually. My name is Stefan Schneider, and I'm kind of like the wood/tech guy. So we're obviously we're really into tech, but I grew up like sort of as a son of a timber framer builder, so we always did stuff with wood, and so that's sort of the direction I went later on. I'm Swiss, as you can probably tell from my funny accent. I've been traveling all over the world, but pretty much settled in North America in the last 15 years. First in Canada, got Canadian citizenship, and now the last almost 10 years here in Portland, Oregon, the US. So yeah, Greg and I, a few years ago, 10 years ago, we started a company, Cut My Timber, and really our goal was to kind of merge craftsmanship and technology. So it's kind of like, how can we, better use technology to do the stuff that our grandfathers did by hand, and like stuff that maybe can't be done by hand. How can we use modern equipment and modern software to do that? So yeah, maybe we'll run you through the slide, and we're open for questions if there is any.
Yeah, and I want to a little bit more background. Oregon produces the most timber of any U.S. state, and the Pacific Northwest has so many trees and booming cities. And essentially the objective is, how do we bring world best technologies and help get them into the U.S. wood business? Just as one of the companies trying to do that, because it's such a big task, opportunity, there's a lot to do. And we think doing it in partnership with a lot of European companies is the best way. So we'll dive in now. Just a second. There we go. For those of you who aren't familiar with mass timber, here's kind of an introductory slide with some of the many kinds of mass timber used on projects. And I think most mass timber projects are a hybrid of materials, not only different kinds of mass timber, but obviously there's concrete and metals in almost every building.
Maybe backtracking a little bit, Greg, before we go
Sure.
through that technical stuff. I guess for those of you that aren't really into the whole mass timber community, it's like, why wood? Traditionally, especially in North America, wood has been considered as a cheap building material. And if people talk about wood buildings, they're thinking 2x4, 2x6 stick frame buildings. In Europe, about 20 years ago or so, we started, there was a huge demand for super high energy efficient buildings. And it became clear really fast that wood has properties that make that a lot easier to build like a net zero energy building or a passive house building. So it has to do with thermal bridging of steel and concrete. So wood is a really good material. It's also a good material in terms of structural strength and weight ratio. And it's probably the only material right now that is fully sustainable. Now, 20 years ago, people didn't care that much, but with everything going on now between climate change and everything, that became a huge issue. So there's that combined with like a political field where, there's a huge need of more housing. And so it just kind of made sense. The last few years, a lot of innovative companies created really cool everything from connection technology, like better glues, better screws. And so we started doing what they call, mass timber buildings, but essentially it's possible now to to build a wood high riser. And even in the US is always a little bit as innovative as they are in tech and everything. If it comes to building, the US seems to lag a little behind in terms of adapting their codes and regulations to the latest available materials. But that really changed everything. And what you see on your slide in the bottom right, that's called a cross-laminated timber panel. And these panels, that really changed everything. And that was a product that came up in Europe out of a desperate need of using low-end wood product. They had what they called sideboards, which is kind of the outside of the tree with really flat grain, and that's not the best possible wood. And so they needed to find solutions to somewhat use that wood because there's just so much of it, and it was, it was just being burned for firewood. And then they came up with those cross-laminated timber panels, and that really made it so we could create a piece of wood in a large format that would behave very similar to a concrete slab. And then with that, like they started thinking about doing high risers and bigger structures. And we see, we'll go as we go through the slides, we see a lot of that. But that's really what triggered it all. And now, I mean, like, again, this is also like everything else. We see similar trends in lifestyle and the way how people eat. But I think a lot of people, they rather live in a healthy building that performs really well and gives you that like cozy type feel, rather than having a big mansion that is built like a cheap way, but it's just huge. So anyway, so we don't have to go through all those materials, but that CLT, this is really what made it possible. And then the other ones, NLT, LSL and stuff, those are just sort of variations of those materials. But CLT is really what enabled all of that.
Another thing that's another and a growing interest in this is because of carbon sequestration. That's becoming worldwide, of course, and then also to the technology industry as they're looking at more environmentally friendly ways to build. Here on the next slide, we'll dive deeper into all of these. We just looked at mass timber products. We'll dive into CNC machines and robotics and software. And I think critically are people. You need the right people who want to move this way. It's, there are some new processes, and so it requires the whole AEC industry, the people, to move together, essentially to make this more cost-effective and efficient. I'm going to play a short video. I hope this comes across. This is inside our factory, and I'll let Stefan narrate this here.
Yeah, so it's not playing yet quite. This is a Cruisematic G1 5-axis machine. And basically that's what we're using. It's a beam processor, but we'll have another slide kind of explaining those different types of CNC machines, but it's a linear machine that only would fabricate beams. But you'll see that it's a big circular saw, so that saw sits on a turntable. It angles, it bevels, so we can do compound cuts. It has drill units, it has slotting units, and so on. So that machine drills, slots, and cuts, and to a really high degree of accuracy. And this is a Swiss machine. We're, to my knowledge, the only company in the US that has one of those machines. There is several in Canada and quite a bit in Europe, and mostly like Western Europe, in Austria, Germany, Switzerland. So, yeah.
Were you able to see the video? Obviously played for me, but were you able to see the video go through or not, Stefan?
I saw it a little bit. It's a little not that fast. It sort of jumps and it sits still, but it's okay. I think everybody was able to see kind of a good view. It's basically, this is a machining center. It's a vertical gantry, and all those units are mounted on a gantry. We'll talk about that a little bit more. But again, if we talk beam processors, here those it's funny, in all my years of traveling, I traveled around and helped a lot of companies setting up those machines and trained them on the software. The one on the top left, that's a Handegger Speed Cut. We have one of those machines too. It's not currently operational because we sort of replaced it with that Cruisematic. But Handegger is sort of the main player in that industry. And you'll see, if you want to buy a machine that cuts heavy timber, you have to buy it in Europe. Like there is some homemade, pretty innovative solutions in Japan, but even Japanese people, they bought European machines. There is nothing really like that made in the US or developed in the US. And in Europe, they're all either from Italy, Germany, or Switzerland. And which, traditionally, those countries have a really strong wood culture, wood industry with, if you're thinking like the wooden ski chalet, a lot of those machines, I mean, that's how Cruzy got really popular. They came up with a machine that would do chalet style connections. But what's important with a beam processor, like the name say, this is for linear beam. So if you have an arched beam that isn't straight, if you have a large format panel that is like 10 foot wide, like a CLT panel, those machines will not do that. So it's like, you picture it's like a tunnel. You see that really good on the top right. The wood comes in either from the left to the right or from the right to the left. And then there's different options. There's some machines have just like kind of different workstations. So there would be a saw unit first, and a drill unit, and a mill unit. And then some more modern machines like the one in the middle, that's also a Swiss machine, a Technowood. They have tool changers and multiple spindles. So the machine essentially takes the tool that is needed for the process, makes the saw cut, puts it back, and would use a mill head or a drill unit. And before all of that happens, you see that on the bottom left, this is a simulation for a Heimdegger speed cut with a revolver mill. So you kind of virtually cut every piece and ensure that you don't have any collisions with rollers or clamping or how you want to clamp. It makes a difference on the quality of the processing. Sometimes wood is a natural material, and depending on how you mill and stuff, from which side you go in, you'll have a really crisp cut, or you would have some splinters. So maybe we go to the next slide and I'll explain the other type of machines. So that's what we typically use. So these ones, there are two completely different categories. So those are gantry and portal machines. They're different names, and essentially it's the same thing. And even within those portal machines, there's two main categories. So you have what you see on both of those upper pictures. Actually, on all three of those pictures, those are mobile gantries. So there is rails on the ground and essentially a table where you put your workpiece on, which is in this case, it's a panel, but that could also be an arched beam, kind of if you picture a large banana or something. And then the machine, drives over it and will process it. So those machines have a bunch of downsides. They mostly process from the top face. So it's essentially a supersized version of your CNC router that you would see in a fab lab or something. It's a mill unit. Instead of a little 1 horsepower router, you'd have like a 70 horsepower spindle. But it's a tool unit from the top, and it would do saw cuts and router and whatnot. The one on the bottom left, that's a Weinmann. There's other brands. Again, this is Weinmann, is German. This is what we call a multifunction bridge, and that's basically part of a wall fabrication line. So there's a wall framing machine that then sends the wall on those tables, and this machine would nail sheets like OSB and plywood to it. It would glue it on if we desire to do so, and it would router out like window openings and plug-in openings and stuff like that. But what they all have in common, they use a lot of space. They're really slow because you're moving that much mass, and the biggest drawback is you can't really process from all six. We always talk about 6 sites, so you can't process from the sides or from below. So if you have a processing from below, you'd have to flip that panel, which is really time consuming and difficult to do. And they're really expensive, and they take up a lot of real estate. So while a machine like that could cut the regular beam, people don't do it just because it's quite slow, and these machines run at fairly expensive hourly rates just because the initial investment is so high. So slow, expensive, cumbersome, But you know, again, if you have a 10 by 30 panel, that's the only machine, almost the only one that will do that. We'll get to the next slide and I'll show you another option. Can you move forward, Greg, to the next slide?
I have
okay, there we go. Yeah. So these are industrial robots used for wood processing. I think you've all seen them. We've been playing the one in the middle center, that's ours. But essentially, it's an industrial standard robot that you would find in an automotive plant or whatnot. And they have a large spindle mounted to it, and then the spindle has a tool changer somewhere on the side so that the machine goes and takes the tool it wants. So the top left, you'll see this is just what we call an end mill. That's essentially a router bit. And then you could also mount the saw or a chainsaw if you want to do, like, you know, plunge cuts and whatnot. The other two machines on the top right and then the bottom, those are, again, gantry robots. So it's kind of a combination of just a regular robot. But you see, it's essentially the same machine you see on the left, but the machine is installed, mounted on a sort of an overhead crane setup, what we would call a mobile gantry or a mobile portal. So just like the machine before, these machines have a gantry that runs on a rail. The workpiece is fixed, and the one in the bottom left, it's in Switzerland. One of my ex-co-workers, he started a really amazing company, and they developed that robot with some robotic companies in Switzerland and integrated it. But what's nice with that, it would do milling, just kind of like you see those other two, but it would also do automated assembly. So it would go over to the side and pick a sheet of OSB, and then it has a nail gun, they would nail it on and so on. And then the top right, that's at ETH in Zurich. That's a really high-level school. And so they have amazing equipment there. So those are multiple robot units also hanging on a giant overhead gantry, and they used it primarily for sort of free-form assembly. So they made parametric designed components that they would then assemble those robots. So what's the advantage of an industrial robot? I mean, the main advantage is just flexibility. They could essentially do anything, assuming there would be software supporting that, and then also the cost and the space requirements. So you're looking at several $100,000. I mean, the top right and the bottom left, those you're talking millions here, but those other ones on the left, this is like several $100,000 for a machine. I mean, you can get a robot like that for about $100,000 now. And then, you know, it's everything else through the tooling and the spindle and those tracks. But it's way cheaper than getting a machine like the ones you saw before. The downside is, like, they're essentially dumb machines, so you have to program a lot. The programming is really time consuming, it's complicated. These machines are not made for sort of one-off prototypes. And, you know, there's many software companies that would tell you, oh, it's easy and stuff, but from our experience, it really isn't. So the way we can create files out of a 3D geometry and send it to those beam processors, this is not the case on those machines. But again, they would do any kind of free-form stuff, like, you know, you see a log being milled so that the piece doesn't have to be square and planed. And so there's a lot of advantages. And I actually think this is going to be the future eventually once this evolves. It's just the flexibility and the cost. And then there's other minor down things, you know, there's vibration issues and geometrical issues and whatnot. But yeah, I think that's probably enough. We can maybe chat about that later when we do questions.
And then in the world of software, this is far beyond your CAD or BIM. There's not even an agreed acronym, but let's dive deep into, you know, wood specific software.
You want me to talk about it? Or
yeah, sure.
Maybe?
Yeah, tell me your background with CAD Work.
So I used to work for CAD Work for 10 years almost, and that's kind of when I traveled around everywhere helping them set up. So CAD Work is a Swiss software that originally got developed at EPFL in Lausanne, so that's sort of the French-speaking equivalent of ATH or ETH, and amazing school, and it was a research project, and that was way back when the Swatch, I guess, I don't know how old you are, but the older of you may remember when Swatch got released, and Nicholas Hayek, that was sort of the Swatch founder, and I'm still to me, he's still a very inspiring man, what he did with the watch industry. The Swiss watch industry was hurting at the time, and nobody wanted to spend thousands of dollars for a watch. And so what he did is he basically said, we want to have Rolex quality, and we want to be able to sell it for $50, and it has to be something that looks really cool. And essentially, that's what I would like to do with buildings. And the way to make that happen was technology. So they said, we're going to reduce the number of components, and we're going to 3D design everything, and we're going to, automate it. Instead of having watchmakers, we're going to have machines doing all the work. So CAD Work at the time, it was called different, but that's why they started it. And so it was basically a 3D modeling software that was made for a lot of components and like fully 3D. That was in a time, it was like almost 30 years ago, 25 years ago. That was even before Windows computers. And so then, this didn't work for Swatch, and it sat there for a few years, and then a wood guy took it over, a wood professor, and they did that. But what it is what we call fabrication information modeling. It's FIM. So think about your Revit, but then you add a whole other level of detailing to it. So we add process data. So when we have a drilling, we already know in the CAD, so we would add a drill hole, and there's macros and things where we would say how we would drill off that. And the software would check for, can it be exported to a machine or not? It would check every single one of those 10,000 components and compare it with the other one and figure out if they're all the same or not, and so on. So there's CAD Work, HSB, CAD, and Theatrix, and they're basically all doing the same thing. So it's like 3D modeling, and then take it to the next level, not just for machine export, but also for fabrication specific shop drawings, like higher levels of details, and also material order lists, nesting, and stuff like that. So that's all integrated. So CAD Work, Swiss software, standalone. HSB CAD is from Belgium originally, but they went a different approach. They took an AutoCAD 3D platform and basically created a plugin on top of AutoCAD with the idea that there's already a lot of AutoCAD user, and they would just sort of develop the missing part of Autodesk so you could have a machine export and files. And then Theatrix, they started out as a sort of a roof development software where you essentially had a giant pull down order. You type in your roof slope and your base floor plan and whatnot, and then the software will create a roof structure and all the all the cutting angles and stuff. And then as it evolved, but it was essentially just a math program, and as it evolved, they came out, that it became more visual and graphically, and now it's a CAD software as well, also standalone like CAD Work. But all these are, you'll see if somebody has a machine like the one we showed you before, 98% of the people would use those free softwares. And then LignoCam on the left side, that's a spin-off of CAD Work originally, which is essentially the CAM export. That's like finalizing those files for the machines. Kind of that's, like CAD Work or HSB CAD would take a geometry and create a machine file, and then LignoCam would essentially, or any other CAM, that would take those machine files, which is like a digital shop drawing describing a process. It would take that and create a tool path for the machine that's essentially telling the machine what to do. And that's also the software that runs straight at the machine. So it's a lot of blah, blah, but I guess the long and the short is like you can't, if you want to fabricate wood automatically with any kind of machine, like what we get, the level of detail we have in a typical architectural model or in a structural model out of Revit is not sufficient. And those softwares, they don't have an export for, they can export the geometry, and then you could take a CAM software and create a machine file, but it's just a very slow and sort of difficult process. So the way to go is that those CAD tools will write what I would call a digital shop drawing with basically a list of all the processes that need to be done at a certain part. So we can talk about that more detail. I can probably talk 10 hours about that, but it's a digital shop drawing where a machine understands it.
Okay, and then we want to essentially show you some actual projects we've worked on to demonstrate the processes. This is a great one. I won't show the video, but obviously if any of you watched a TED Talk, this is the TED stage that's been taking place up in Vancouver, BC.
So this is all made out of engineered wood, all architectural grade glulam, locally sourced here in Oregon. And the challenge of that is like, they approached us about a year prior to the event and gotten pretty quiet. And then suddenly like about 2.5 months before the event, they came as like, this is what we want. Can we have that in 2 months? And I was like, so you're looking at 12,000 wood components and about 10,000 of them were individual. So they all sort of look the same, but they all have different angles. And so that's the back side of it. And then the front side is a U shape, like a seating theater kind of sort of inspired by a Shakespeare layout theater. And that was done by an architect in New York, like really cool, like Rockwell group. So a cool project. That was actually, we've never cut as many components in such a short time. So we're already fabricating parts that while we're still designing the other half of the structure. And that would have never been possible if we didn't have technology. I mean, it was amazing. We would cut components on 3 different machines and sort of, real time and, parts that would have to fit together. So that was cool.
And this Albany Yard?
You want to talk about that, or should I talk about that?
Go ahead.
Just basically the same. This is almost our home project. That was the first mass timber building in Oregon, probably also one of the first in America. It was the first time a West Coast company made CLT, Douglas fir CLT panels. So they sort of approached us to help them on the final detailing. We knew the architect and it's like, oh, we need some help with that. But essentially, if you would look at that, a steel structure that looks the same or a steel skyscraper, you'll see they're all built the same. There's a structural skeleton, there's columns, beams, and then typically in steel, they will put like steel sheets on it and pour concrete. So this is the same type concept. There's a structural skeleton, but instead of HSS steel tube, we would use glulam columns, glulam beams, and then those CLT panels that you saw before. So those panels are 10 foot wide, 30 foot long, and so because they're so big, you can do 300 feet like every 10-15 minutes. You can just crane in one panel after the other. So that was sort of the prototype of the concept. We learned a lot, and for me it was very cool project because we had amazing architect. We still work with them. I love the whole, and not just the architect, but their whole firm is great. It's Lever Architecture. That's their office. We had a really good engineer. And for me, this is, everything came together, like new cool materials, innovative connectors. So it's kind of the forefront of timber engineering, fabrication, tech, everything, and cool design. So, and based on that, we started developing a mass timber sort of standardized skeleton approach. All those connections have to be concealed for fireproofing and whatnot. So this was sort of, we did a lot of tests and calcs, and so that was sort of the prototype for what we've been doing after that.
And this is, again, another one. This won a bunch of awards, as does the previous couple of projects. This is actually just completed.
Yeah, very similar approach. I mean, it's different. What you don't see here, I think that's a rendering. Maybe it is a photo. I don't know. It's hard to say these days. But what you don't see here is, the back side of the building is actually 1 story taller. So the road to the right is like about 10 or 12 foot below this level. And so also the floor plan, it's all tapered and has a kink in it. So it was a really tight site. Everything had to be just in time delivered. But structurally, same concept, like glue lamp skeleton, concealed connectors, and CLT panels that would make the shear diagram of the whole building. And you know, got the one on the left that you see with all that glass, that's a concrete and steel building, mostly concrete, and they're forming. It seemed like forever putting their post tension concrete in it, and it's just you know, we were just kind of flying, like basically every day we would put a floor, and the floor was like more than 6,000 square feet, and it would just kind of keep going up. So so really cool project too, and really kind of proved, I'm convinced we could do the same thing. It goes towards the building behind, and this would still work, which is sort of new, and people are, you know, this is going to happen here soon. Same, Adidas, we've been doing really well with all those sports companies. As you know, they're all, or not all, but a lot of them are headquartered here in Portland, Oregon. That's Adidas. We've also done quite a bit of woodwork for Nike. They built the new campus. Unfortunately, their main campus is all like structural steel, and then they have a lot of wood components with it. This one is all wood. There's two buildings. One is completely in wood. The other one is concrete, precast concrete, so offsite concrete, and then wood floors and floor panels. Same architect level, they did that, and same as they, you know, that office you just saw. I think they integrated a lot of lessons learned from their own office and just kind of scaled that up. It was huge building, and a lot of repetition in it, which is kind of makes it a little easier, like as opposed to like the TED where every single corner is different. Okay.
Yeah, just talk a bit on passive house. Another thing, obviously most common in Europe and especially Germany, but this is a West Vancouver project.
30-second thing, I don't know, a lot of you probably do know what a passive house is. There seems to be a lot of confusion between net zero and passive house, and passive building and solar passive. But passive house is somewhat, and I don't know what the legal stuff is about it, but it's a standard. It's not a brand or anything. It's a standard that was developed in Germany, and the idea was really a hyper insulated. Basically, how can you design a house that has a limited amount of energy consumption while operating per square meter or square foot? So it was like 15 kilowatt hours per square meter per year, and that's, you know, that's not very much. Like a typical US built by code modern code home, you're looking about 200, I think. So you're taking out down to, or you kind of engineer it down to using about 10%. And the way to make that happen isn't like photovoltaic and solar panels. What it is, it's a really good building shell. So you take away all thermal bridging. You design it in a what we call a compact geometry. So essentially a box, but you don't want to have like a lot of, you know, weird bump outs and stuff. So all those things, they cause the thermal performance to go down. But it has nothing to do how green the resources are that we use to build that house. So this is really just how well does that house perform. So it's a performance-based standard. And it's incredibly difficult to do. There's a lot of almost passive houses that are not certified, and people claim they are. But the main thing is lots of really expensive windows in the south side, no windows in the north side, and then, you know, really thick, super insulated walls. And then additionally here, this is done with CLTs. All the walls are fully wood walls with super modern prefable membranes. So that the objective was like creating a building envelope that performs sort of like your Gore-Tex jacket with a bunch of like high performance fiber sweaters below. Like, so you have really good insulation, but it's also fully breathable. And then it didn't hurt that it was an amazing location to this. You're basically looking straight at Stanley Park in Vancouver. So West Vancouver is kind of the Hollywood Hills of Vancouver, BC.
And this one, we worked on this project. It's in Corvallis, Oregon State University. This is exciting because Oregon has so many projects going on in mass timber, and OSU and U of O endeavor to be essentially the premier research center for tall wood and mass timber in the United States. So we have a great relationship with them, and they have a showcase building.
I say that as a Swiss guy, a lot of people probably don't. And I just throw that out there. This is my personal opinion. That's not, I mean, there's facts sort of proving that too. But I really think in the Pacific Northwest, we have some of the best wood in the world. And I worked in Australia with wood. I worked in some Asian countries. I worked everywhere in Europe. We have really good wood in Europe too. But it's just Douglas fir is like what I think by far the best, you know, like the strength, the appearance, how it behaves, how it can be fabricated and worked with, not just CNC fabrication, but if you take a chisel or a hand saw, you cut the piece of Douglas fir. So it's a really good wood, and there's a lot of it. And we can't, a lot of people's like, oh, we shouldn't cut all those trees down. But the thing is, with those panels, we're using small boards. We're not cutting the big old trees down. We're using small boards of material that needs to be cut out to keep those forests healthy and to prevent them from having, you know, becoming victims of forest fires. But unlike, I mean, Canada uses a lot of SPF, spruce, pine, fir. In Europe, we use a lot of spruce, but the Doug fir and you know, the deflection strength, the E-module, it's a superior wood. And I'm really happy I think we couldn't be in a better place because we can source everything locally and it is the good stuff. We don't have to compromise because of where we're at. And you know, OSU, obviously they used all relatively local material.
Well, and big picture, this is what really excites me. As you've seen throughout the presentation, so many of the machines, the CNC machines, so much of the software, and essentially the experience, a lot of that is coming out from Alpine Europe. And here we are sitting in the US, in the Pacific Northwest, which has the most trees, shortages of housing. We've got that abundant wood. So why don't we use the best tools and the best processes to create local jobs using local material to do green building? And I think we also have all the tech industry here as well. So if all of that converge, there's massive opportunities for many companies in specifically mass timber. Here's a really fun project. We won't have time to dive too deep into this. Google is really committed to mass timber. They were building a planned timber district in Toronto, Quayside. Unfortunately, that was recently canceled a couple of months ago, but they're still completely committed to essentially commercializing mass timber as an industry. And Google itself can consume billions of dollars of mass timber for its own buildings. So we engaged with them, essentially creating this STOA prototype, which went up in Toronto. And I'll have Stefan give you some more background on that as well.
Yeah, I mean, you can Google that. There's it's not the wood buildings and mass timber buildings. That's just one part of it. But they spent millions and hired some of the smartest people to really create how is the future of living going to look like? How can we create those cities better? Logistics, deliveries, health, you know, like work-life balance, all of that. And that was really clear that, you know, they want something fully sustainable. And, you know, pretty quickly they decided on wood, and the more they understood it, the more they were committed to it. So the project here, this is that the goal was like, we want to give people the opportunity to go on the base floor of a 35-story or whatever the size it's going to be skyscraper, and kind of, you know, what would that take? How big would those columns be, and how big would those beams be? And you know, it doesn't look like much, but that display, I believe those tables are at the normal table height. So on the back right side, that's a column made of a double glue lamp. Those are 4 by 4 foot, like they're huge huge columns. I mean, that's a huge chunk of wood. But realistically, if you want to do even a 10-story building in wood, your loads coming down are so enormous that you will need a big piece. Those beams you see, they're about 4 foot tall, and each one is 12-inch wide, and then there's always tandem beams, but they're 40 foot long. So we were able to help them just kind of, develop that prototype, and everything was like real scale. So you could put another 20-story or whatever on top of this display, and it would work, right? So everything that the connections are obviously for this display way overbuilt, but they just want to do a mock-up of the real thing and in real size, not just kind of scale it down. But yeah, really cool experience. I've never actually worked with Google, and this wasn't Google itself. It was a company called Sidewalk Labs, and they, really great people. It was a lot of fun, and it's good for me. It was a good experience because we're so, trapped in our wood world, if you want, but working with other really smart people was fun. Just that they just have a whole different look or a different perspective on that. So I very much enjoyed that, and I hope this will continue to evolve.
Yeah, and Google's committed to it. You can Google that. Well, yeah, you could research that. They publicly stated they're going to continue with this. So Microsoft is building some mass timber buildings, and to me, it's where the tech industry starts to support wood as a carbon sink, also using technology for sustainable building, both as a client and as a partner developing technologies to make this scalable. I went to a conference in New York City. I was invited to it in 2019. It was investment opportunities in mass timber. A lot of finance people, and also Google Sidewalk, Kareem Khalifa was there, and he gave this presentation where Google wants to go. And the reason I included this slide, and this is simply my cell phone picture of a screen of the Sidewalk presentation, but I want to draw your attention to what Google was projecting. Essentially, how could they develop systems to help to use 4.1 billion cubic meters per year of mass timber? Just think of that sheer quantity, and they see it as helping address homelessness. They see it as helping address sustainability, and they settled completely on both passive house as the green standard and mass timber as the preferred material. This is also, I think, this is a free downloadable report by primarily the organizers of the Mass Timber Conference. You can see the name of the report on the side, 2020 North American Mass Timber Report. And although these projections are speculative, we don't know if that's true, just look at the hockey stick or exponential growth curve in the sheer number of mass timber buildings. And that's why I typically tell people, the opportunities are so vast, they're beyond any one company, and we need thousands of people entering the industry. Not only that, we need building systems so we can build this many buildings. In the U.S., as already the largest market for wood-framed buildings in the world, we have an unprecedented opportunity, and so we're happy to play a small role in helping make that happen. And for those of you interested in mass timber, I want to point out some upcoming events. I have a U.S. Forest Service Innovation Grant to organize mass timber events and an online global design competition. I'll share more about that. But we're also excited to already have confirmed events coming up in Switzerland in March 2021. Again, that'll be another AEC Hackathon. And there will be a lot, the Swiss universities on the left, and many leading industrialized construction, robotics, and timber companies and organizations all meeting together for a week of events. Building Smart, AEC Hackathon, and then the Industrialized Construction Forum, organized by Stanford and ETH. Stefan and I have been and presented mass timber at Stanford. And Stefan is also a graduate of Bern University. Stefan, I could share a bit about that. This is your home territory.
Yeah, I guess, yeah. That's a long time ago, but yeah, I did go to that school. And we also worked, I did some parts at the EPFL on the left, École Polytechnique Fédérale. They're all good schools. So yeah, So it's good to work together kind of on a more international field.
Yeah, and I think from a technology, sustainability, innovation, to me or to us, the fastest way forward are what are the best processes, tools, and technologies in the world, and how do we help those scale those? And in our particular case, how do we help bring those to the US and localize them? And our primary focus is the US West Coast, but we see that as potentially the biggest market and also home to all the technology companies in the fast growing cities and the wood. We're going to run out of time soon. I want to get to questions, but I do want to share this. I organized a mass timber hackathon in Portland with all the companies on the right. I had to postpone that, of course, due to Corona, but we am going to repeat that also in March of next year after being in Copenhagen, a week, Digital Construction Week in ETH in Zurich, and then we're going to have a 3-day conference in Portland, Oregon. And it will be immediately followed probably by 2,000 people coming to the Mass Timber Conference. So check into the Mass Timber Hackathon website to find out more about that. And there are a number of groups emerging to essentially, how do we bring mass timber online? Online meaning where do you go to find out about projects, best practices, and essentially the supply chain. This is where I want to go. We want to help make this happen and help it, such an organization and community be founded internationally by a lot of partners in Europe and partners in the US, people in tech companies from the tech industry, from AEC, from real estate, and also investors. Let's make this happen. That's essentially, and we're in discussions of how to do that. Groups are emerging, but essentially it will happen. We just want to make it happen faster. And that brings us, Jen, I think we can get to questions. We're already at 50 minutes. That's Stefan and my contact information. If any of you want to contact us directly, and also I want to jump in and see if there's any questions that we can for discussion.